Welcome once again to Scientist Arena. In this video, we shall be looking at work, energy, and power. Alright, so now work done is the product of force F and the parallel distance S moved in the direction of force. Alright, so we say work done is the product of the force F and the parallel distance S moved in the direction of force. Now, one important thing you should know that is that when there is no displacement, when a body is not being moved a distance by force, work done is equal to 0, because this is just saying that force times distance. When there is no displacement, the body is where it is, there is no distance, that means distance is equal to 0. All right, and anything multiplied by 0 is what? 0. So it means that what? Work done will be equal to 0 when there is no distance being moved by the what? Body. All right, so now we have different formulas for calculating our force, we have different formulas for calculating distance. All right, so that gives us variety, a large variety of formulas for calculating work done. All right, so for calculating force, we can use the formula ma, that is when it is being accelerated by the force. We could use mg when it is falling under gravity, that's free fall. We could also use coefficient of friction multiplied by R. All right, so that is used when we have frictional force being involved, when it is being moved by frictional force. We could also use F cos theta, that is when it is inclined to the horizontal, and F sine theta when it is inclined to the vertical. All right, then for calculating distance S, we have we could have it as S is equal to AT plus half GT square or half AT square. All right, it could also be equal to V square over 2A. It could also be V square over 2G, and we know that S is the same as what? H. It could also be H, that's height. All right, height moved. Right, so with this now we can get different formulas for calculating work done. All right, the most common one being mgh. All right, we could have mgh. If frictional force is involved, we could have we could have it as we could have it as rgs. All right, then we could even still break this r down. We know that r is equal to mg. All right, so we could have it as mgs. All right, so whatever, with this you can derive different formulas for what? Work done. All right, then we could also have h. H is being, H comes into play when we have the load going down a slope or hill or a staircase. All right, so H in the case of a slope, H in the case of slope will be L sine theta. All right, it will be L sine theta, where L is the length of the slope and theta is the angle of inclination. All right, it could also be equal to height of the step times number of step. All right, it could also be height of the step, that's in the case of a staircase, height of the step times number of what? Steps. All right, so with this we could derive as many as you would want formulas for what? Work done. All right, physics has to do with you knowing the fundamental formulas. When you know the fundamental formulas, you will be able to get any formula of your choice regarding the formula. Actually, you just have to know a formula. All right, then after this we have what we call the force distance graph. All right, we have what we call the force distance graph. All right, so the area of a force distance graph is equal to what? Work done. All right, so the area of a force distance graph is equal to what? Work done. And for this we have two major types or two major criteria with about 5 different force distance graphs. All right, so the first one, we could have a case of constant force and varying distance. moved. All right. So for this, we could have a graph like this. For this, we could have a graph that looks like a square or rectangle. All right. And we said the area is equal to what work done. So the work done of this kind here is force. Measure the Newton and distance in meter. All right. So the area of this now, the area of this which we work done will be equals to what? F times what? S. That's force times what? Distance. All right. Then another case we could have is case of varying force and varying distance. All right. So for this, we could have a case of let me try to manage this space where here is force, Newton, and here is distance. All right. So for this, we could have something like a quadrant. All right. We could have something for a quadrant, and the work done here will be equals to 1/4 pi r square. All right. That's for a quadrant. That's the area of a quadrant. All right. We could also have, let me put this as I. We could also have II, a case that looks like a semicircle. All right. This could look like a semicircle. All right. So the area, which is the work done there, here we have force. Still the same format actually, the force distance graph. Right here we have distance measured in meter. All right, so the work done here will be equal to what? The work done here will be equal to the area of a semicircle, which is equal to half pi r square. All right, another scenario we could have is that of, let's say, a triangle. That of a triangle. This is force in Newton. This is distance. Don't mind my drawings though, in meter. All right, so we could have case of a triangle. Right? And for a triangle, the work done is equals to half what? F times what? E. Alright? Then lastly, we could also have a scenario of a trapezium. Alright, where this is force, Newton, distance, meter. Alright, we could have that of a trapezium that looks like this. Alright, so for trapezium, we could have the work done, which is the area of a trapezium, to be equal to half a plus b times what? Height. All right. So this is all about what? Work. So one important thing you should know is that work is done only when there is what? A distance being moved. All right. So now when work is not being done, it has energy, which we shall talk about in the next video. Now, energy is the ability or capacity to do what? To do work. So while it is still at one position, without it being in action, it has what? Energy, but it is not undergoing what? Work. So it has potential what? Energy. We shall talk about this in the next class. So it has the energy to carry out the work, but it is not carrying it out. All right. So in that case, whereby we have somebody putting a bag of rice, the bag of rice is on his head. I know you'll be like, this bag of rice must really be heavy for him. But at that point, he's not doing what? Work. He only has what? Energy. All right. See you in the next video when we shall be talking about energy. Please don't forget to like, share, subscribe. Thanks for watching.